Hello, Jonathan Wagner here from solidzymes.com, and today I'm going to show you how to analyze an image from an SDS-PAGE gel using the ImageJ software. The first thing you need to do is open up ImageJ. It gives you this little bar of tools, and then you can go to File up here in the toolbar, and you can choose your image file. Now this is a gel that I ran the other day. I put it on top of a light board and took a picture with my phone. And the picture is sideways, which is a problem. We need it to be up and down. So I'm going to go to Image, Transform, Rotate 90 degrees to the left. Okay, so that puts the gel in the most familiar orientation. And then I need to make it black and white, so I'm going to go back to Image, type 32-bit. Okay, so that makes the image black and white. Now, what I'm doing with this gel is I want to quantify the purity of my protein that I'm purifying, and I want to compare it to some BSA standards of known concentration. So the first lane here is a ladder. The second two lanes are my protein of interest, and you can see the big band here with some contaminating bands lower in the lane as well. So I want to compare this big band to all these little bands, and then starting from lane 4 I have standards of BSA protein. So I know that there's 4 micrograms in this one, 2 micrograms in this one, 1 microgram in this one, and so forth. So I'm going to compare the size of my protein of interest band to these standards as well. So ImageJ is going to help us do that. First thing that I want to do is draw a rectangle around the first lane. And I want to make sure that I get the whole lane. So I'm going to drag all the way from the top to the bottom. And then I'm going to hold down the Command key and I'm going to press 1. If you're using Windows, then you need to hold the Control key and press 1. Okay, but as soon as I do Command 1, you see the number 1 pops up in my rectangle. And this is basically saying, okay, we've analyzed this section. Now I need to give it the next section that we're going to compare to. And in order to do that, I just need to bring the mouse over to this rectangle, click and drag. And when I do that, it makes a new rectangle. I can drag it over to the next lane. It's going to be exactly the same size, and it's going to be at the same place up and down. I can really only control the position of things horizontally. And once it's in place, I'm going to hold down Command key. I'm going to press number 2. Okay, so number 2 pops up in this rectangle. And this is where it gets a little confusing because I'm going to click and drag again from number 2 over to the next lane. And I'm not going to hit Command 3. I'm going to hit Command 2. This is just the next lane. So Command 2, number 3 comes up. Click and drag, Command 2. Now watch what happens if I try to move the rectangle down in the lane. I hit Command 2, it pops back up into place. So this is why I'm saying you need to get a nice generous rectangle to make sure that you get everything in all the lanes as you go across. Because once you get started, you can't control how long those rectangles are. Okay, so click and drag. These are all the lanes that I need for this analysis. There's 7 of them, and now that I have them all defined, I'm ready to hit Command 3. So I'm going to hold down Command key, press 3, and now it brings up the graphs of the darkness of the image. So you can see here on the left of this pop-up, this is the top of the lane, and it's not too dark because there's no protein there. But this is the first big band. You see there's a big peak here from that big band. And then farther down the lane there are some small peaks. Now, this is probably a good time to talk about the peak sizes and staining. So it's important to be consistent with your staining and destaining procedure for the gels that you analyze, because as the gel is destaining, the intensity of these peaks kind of erodes, but it doesn't do so evenly. The small peaks actually erode faster than the large ones. So if I was to come back to this gel after more destaining, what would happen is these small peaks would be almost gone, and this big peak would be almost the same size. So I would get a different number for protein purity. And we don't want that, so you always have to be consistent with your staining and destaining protocol. All right, so the next step with this graph is I need to define the baseline. And in order to do that, I'm going to go back to my little toolbar in the top right, click this line segment tool, and drag a line across each of my peaks. So there's 1, 2, 3, 4, 5 peaks. I'm not going to do this last one because that's just the dye front that didn't quite run off the gel. That's not a protein. And I'm going to do this for all of my peaks really quick. Trying to do everything consistently. These are the BSA peaks now. If I'd used a higher resolution on my phone, I wouldn't have so much noise in my baseline. So you might want to do that. Just use a good quality picture or scanner if you're using a scanner. Okay, so I've drawn my baselines, and now I need to integrate the peak areas. So I'm going to go over to this wand tool, click that, and then I'm going to click inside each of the peaks. And you'll see that it'll turn yellow, and a pop-up will come up over here showing the integrated areas inside each of those peaks. And what I'm going to do is highlight that table of numbers, and I'm going to copy paste it into Excel. So put it there in Excel. This is lane 1. Okay, that's the 5 peaks from lane 1. And then I'm going to take this little pop-up of peak areas and get rid of it. I'm not going to save it because I have it in Excel. I want to make another pop-up window with all the peaks from lane 2. Okay, and it looks like I actually missed a peak here, so let me go back and draw a line. Get that peak. Okay, highlight that, copy paste to Excel. Lane 3, so on and so forth. So I'm not going to go over all the lanes. I've already done this. I just want to show you the results really quick. So at this point, we're going to go to Excel. In Excel, I'm going to graph all the peak areas and compare them to the standards. So okay, so here's the results. So this is the gel, remember. My protein of interest is in lanes 2 and 3. And these are my BSA standards. And you can see the standard curve that I got from the integrated peak areas. Okay, so the peak areas go up as I add more micrograms of ESA protein. And this kind of illustrates what I was talking about with the small peaks eroding more quickly as the gel destains. You can see it doesn't make a linear line. The small bands are actually smaller than you would expect them to be. And that's that effect I was talking about. So again, be careful with your destaining. I was able to fit this to a nice line anyways and calculate the concentrations of my samples from it. So what I got using lane 1 was 48% purity. So this large band was 48% of my total, and 8.67 mg per mil of that protein. In the second lane, which is just another sample of the same protein sample, I got purity 46%, so that matches. But for the amount, I got 6.19 mg per mil of this protein. So this just illustrates the fact that you need to take your results with a grain of salt. So this gives me an estimate of how much protein is in my samples, but really what I need to do is finish purifying this protein, do some size exclusion chromatography, and then use a spectrophotometer to measure the absorbance at 280 nanometers once I have a pure protein sample. That's what I'm going to do, and hopefully by the end we'll get a much better estimate of the protein concentration that I have. But ImageJ is going to be helpful to estimate things in the meantime. Also, we don't always have enough protein to use a spectrophotometer, so there's a lot of applications for ImageJ when you only have a tiny amount of protein, just enough to run a gel. So I hope that you enjoy using ImageJ, and if you like this video, hit like, subscribe. If you're interested in what we do at SolidZymes, or if you would like to hire us to do some protein purification or expression work, please come visit us. You can always send me an email to jonathan@solidzymes.com, and I'd love to talk to you about this video. So with that, thank you for watching, and I'll see you next time.